Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today, the overview of presentation includes logical implication and principle of duality. So, let us see the first one, that is logical implication. So, here, let us see the logical implication definition. Let P within the bracket here we have P1, P2, P3, so on, and Q, P1, P2, P3, so on, be two propositions, then the following conditions are equivalent. So first here let us understand what is this propositions P and Q. So here let us suppose here I am denoting a proposition with the capital letter P. So in this place here we have P1, small p1, small p2, small p3, so on. So this is nothing but here you can have any compound statement. So that compound state can be P implies Q, P by implies Q, P or Q, or we can also write it as here P and Q. Means this P1, P2, P3 are called variables, and in that variables you can include any number of variables in form of the compound statements. And here we have another statement here, that is P1, P2, P3, so on. So, and this comes under the Q proposition. So, this Q is nothing but similarly we have P, in the same way we have Q here. So, in place of Q here we have P1, P2, P3, so on up to Pn. So, these are the two propositions. So, let us suppose here we are considering two propositions, capital P and capital Q. So, if these two are propositions, then we can say that the following conditions are equivalent. So, what are those conditions? Let us see here. First condition is negation P. So, this negation P means it's not variable. So, we can consider this is called a proposition. So, that proposition can be anything. Means here negation of some compound statement you can write. That is either can be P and Q or P or Q. Like that we can consider any compound statement, or Q proposition. Means here or Q proposition means in place of Q you can have any proposition variables in terms of compound statements. So on the whole you have to get in the form of negation P or Q. So, this P is not a variable, you have to understand. This is called a proposition. And Q is also not a variable, it is called a proposition. So, in terms of these propositions, we can have any compound statements that we have discussed here in P and Q. So, and that must be a tautology. So, negation P or Q is a tautology. And also the second condition is P of P1, P2, P3, so on, and Q of P1, P2, P3, so on. Here, not only P1 here, I have just represented the variables with the P. You can also represent these variables with Q also. So, E is a contradiction. So, here, negation P or Q is a tautology. P and Q must be a contradiction. And the third condition is here, P implies Q. Here, P implies Q must be a tautology. So, here all the three conditions are here. So, simply if you write here negation P or Q, P and Q, P implies Q. So, here negation P or Q we have to get tautology if you construct the truth table. P and Q if you construct the truth table you need to get the contradiction, and P implies Q you have to get the tautology if you construct the truth table. So, and these truth tables you have to conduct, and you have to construct these truth tables, and you need to get these answers like tautology, contradiction, and also tautology. So, only for this particular conditions you need to get. And we can say that these conditions are equivalent if P and Q are propositions. Now, let us see the formal definition of the logical implication. So here the definition of the logical implication is a proposition P, P1, P2, P3 so on, and here it is logically imply a proposition a Q, P1, P2, P3 so on. Then here if one of the condition is holding, means we can say that P is logically implying a proposition Q if one of the condition holds. One of the condition means here what? Here we have seen three conditions, that is negation P or Q, P and Q, P implies Q. And if any one of the condition is holding, then we can say that a P proposition is logically implying a Q proposition. So if P is logically implying a Q proposition, we can also represent this symbolically by denoting it here two lines, one side arrow. So logical equivalence is two lines, two side arrows. That is, we have discussed in the previous session, and here we are discussing logical implication, which is represented symbolically here two lines, one side arrow. So here if P is logically implying a proposition Q, then symbolically it is represented by writing it here P so on, here P1, P2, P3 so on logically implies Q, P1, P2, P3 so on. So this is a formal definition of logical implication. Now let us check here by constructing the truth tables of each condition here. That is, the conditions we have here is three conditions: negation P or Q, P and Q, P implies Q. So for each and every condition, let us consider one example, construct the truth table, and let us check whether we are getting this respective tautology or contradiction or not. So here, this is about the formal definition of the logical implication. So here we have the first one, negation of P or Q or Q or P. So if we observe this question here, it is in the form of the first condition. What is the first condition here? Negation P or Q. So here if we observe, this is negation, and this whole I am considering it as P, or this whole I am considering it as Q. So this P or Q is P, Q or P is Q, negation P or Q, which is our first condition, and if we construct the truth table here, then we will get, we should get the tautology. So let us construct the truth table for the given question and check whether we are getting tautology or not. So here, so as we have here P, Q, two variables, so let us consider here P variable, Q variable. Next here we need to have P or Q. Next negation of P or Q. And here we have also there Q or P. And we also have here the total question also we need to write. That is nothing but negation of P or Q or Q or P. So now let us see the truth tables: true, 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 false, false, true, and here we have P or Q. So next, the fourth one we also have false, false. So next here we have P or Q. So here or is nothing but here disjunction. So the condition to construct the truth table for the disjunction is, even if one statement is true, then the resultant truth value will get true. So in the first row, as we have two trues, then you will get the true obviously. And in the second row, we have at least one true. In the third row, we have one true. So in the last row, as we don't have any true statement, you will get the false statement. So next we need to apply the negation for the P or Q. So apply negation. Negation is nothing but here. Applying the negation is nothing but here. You are going to get the opposite statement. Means if you have true statement, you will get the false. If you have false statement, you will get the true. Now as we have true here, you will get false, and next also false, next also false, and here you will get a true. So next we have Q or P. So here Q or P means first you need to consider the first statement as Q and the second statement as P. So and the same here we are applying disjunction. The same condition, even if one statement is true, the resultant truth value will get true. So here true, true will get true, and true, false you will get true, false, true you will get true, false, false will get as false. So next here, this one and this one, that is nothing but here we already achieved this. Here we are already achieved this negation of P or Q, and we have achieved Q or P also. In between these two columns, you need to apply OR. OR is nothing but here again disjunction. So even if one statement is true, the resultant truth value we should get true. So here true, and here we have true statement, that's why we will get true, and here we have true statement, we will get true. In the last row also we have the true statement, that's why we will get true. Now if we observe this last column, we have all truths. So here what is the question here? So here the condition, actually we have negation P or Q. Whenever you construct the truth table here, you need to get the tautology. What is meant by tautology? If the last column, if we are getting all truths, whatever the variables, even if you have 2 variables or 3 variables or 4 variables here, if the resultant column, if you are getting all truths, then we can say that it is called a tautology. So here if we observe, so we got all the 4 truths, then we can say that this negation P or Q is satisfying the condition. Then here we can summarize that P is logically implying a proposition Q. That means this P proposition is logically implying a proposition Q. So this is logical implication, and we have seen as one condition, this condition is satisfying, that is negation P or Q, we are getting tautology, then we can say that it is a logically implies. So now let us consider another example also for another condition. So here the second condition is P and Q. So here P and Q we need to get the contradiction. Contradiction means a statement formula is said to be contradiction if the resultant value, if you get all false. This is called contradiction. Now let us see the example for the contradiction example, that is second condition, P and Q and negation of P or Q. So the condition is here, let us suppose I am representing this P and Q as only P, and negation of P or Q I am total representing it as Q. So this is in the form of the P and Q propositions. Now when we can say that P is logically implying a proposition Q, if we are getting contradiction. So now let us construct the truth table and check here. So here first P variable, Q variable, next P and Q, and here we need to find out here P or Q also. Next negation of P or Q, and also the last question is on the whole P and Q and negation of P or Q. So here, so same 4 possible combinations, true, 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 false, false, true, false, false. So next P and Q. So and is nothing but here conjunction. Conjunction means here even if one statement is false, the resultant truth value will get false, otherwise it is true. So here as we have all the true statements here, then we will get as true only, and we have the false statement in the second row, will get false statement. Third row also we have the false statement, will get false, and in the fourth row both are false statements, will get only false. So now here we need to consider P or Q. So what is P or Q here? So P or Q means conjunction or disjunction. Here we have conjunction is completed and P or Q is disjunction. So here what is disjunction? Even if one statement is true, the resultant truth value will get it as true here. So we'll get as true, 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 and all. Next is false. All truths and next is false. Now apply the negation for the P or Q, then we'll get opposite here, false, true, true, true. So here we have the false statement, here we have the false statement, here we have the false statement, and here we'll get the true statement here. So next, P and Q and negation of P or Q. So here if we observe, P and Q is already done, negation of P or Q is already done, and in between these two columns you need to apply the AND here. So if you apply AND here, even if one statement is false, the resultant truth value will get it as false, as we have the conjunction here. So then we'll get false, false, and here we have the false, and also we have false. So now if we observe this last column, which is here P and Q and negation of P or Q, so we get all the false statements, then we can say that this is a contradiction, and this P and Q is a contradiction. Since it is a contradiction, then we can say that P proposition is logically implying a proposition Q. So this is the example for the second condition, that P and Q is a contradiction. Now let us see the third example. So what is the third example here? Let us recall this one. P implies Q is a tautology. Means this P can be a proposition, Q can be a proposition. So in place of P, you can have any number of the variables, any number of statement formulas. In place of Q, you can have any number of the statement formulas. Whenever you apply in between those two propositions, if you apply this implication, you need to get the tautology. Now let us see here the third condition example. P and Q implies R implies P implies R. So that means this total you have to consider it as P, and this total you need to consider it as Q. So here P implies Q must be a implication. That is, P implies means what? Implication. So the P implies Q, here you need to get the tautology. Now let us apply here. So as we have three variables, so obviously you need to construct 8 possible combinations table. PQR. Next you will get as P and Q. Q implies R. Next you need to write P implies R. So next here P and Q implies R. So on the whole, next resultant value. So here first let us go for the combinations true, true, true. So next true, true, false, false, true, true. Next we have TFT, that is in between false. True, here if you observe in the three combinations, we have considered true two statements and one false statement that we have interchanged here. Next we have false, false, true, false, true, false, and here T, that is true, false, false, and at last false, false, false. So here we have the fourth column, that is P and Q. So if you have P and Q here, so this is end is nothing but conjunction. So based on the conjunction, you need to construct the truth table here. You will get true, true, false, 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 again false, and again false. Why? Because if you observe true, 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 in the rest of all the cases, even if one statement here we have the false, that's why we are getting here all false. Now go for the Q implies R. So second row and third row. So if you go for the second and third, so we have here, what is the implication concept here? If the first statement is true and the resultant truth value, here you will get first statement true and the second one is false. The resultant value you will get it as false statement. So true, true we have here true. So here we have true, false, then you will get as false here. Here we have the true statement, and here we have the true. Here we have the true. Here we'll get false statement. Next is true, true. Now, so let us go for this first, this column, that is P and Q implies R. That means in between these two columns, I am going to apply the conjunction. So conjunction means here you will get a true. So here you will get false statement, false statement, false statement, false, 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 and false. Means except the first row, the rest of all you are having the false statement. So even if one statement is false, the resultant truth value will get it as false here. That's why we are getting all false statements. Now let us go for this P implies R. P first column and the second one is, second means third column is R here. Now apply for this implication here. If you apply the implication, the first one true, second one is false, third one is true, fourth is true, fifth is true, sixth one is also true here, seventh one you will get false, eighth one you will get true. Now, so the resultant, what is the resultant answer here? So the resultant is nothing but here P and Q implies R implies P implies R. Means the first statement you need to consider this one, Next, the second statement is P implies R. Means you have to go from here right to left side. So that is here true is true, and here we'll get true, true, and here we also get true. So true, and true. So if we observe here, all the statements you are getting true. Why? Because implication is nothing but here, if the first statement is true and the second statement is false. See here, what is the first statement here? P and Q implies R. Now if we observe here, we don't have here true statement in only except in the first row. And if we observe the second statement, we have true. So in this true and true, you'll get true. In the rest all, you'll get as true only. So as per the condition of this implication here. So now if we observe this, we got all truths, all combinations, 8 combinations we have truths only. Then we can say that this is called a tautology. So this is a tautology, and this is the example for the third condition here. Then we can say that all the conditions are equivalent here. Now, as this is a tautology, as this P implies Q is getting a tautology, then we can say that P proposition is logically implies a Q proposition. So we have seen one example for each and every condition, and we have seen that P is logically implying a proposition Q here. So this is about logical implication. Next, we also have one small concept where we can expect for 1 or 2 marks questions per short answers. That is called principle of duality. So in the name itself, we have duality means what here? 2. So that means here, so we have the 2 operators. So that is OR AND. So let us see the definition. Then you can understand with the help of example. The dual of a statement formula is obtained by replacing OR by AND or AND by OR. So that is in the question, whenever you have OR, you have to replace with AND. Or if you have AND, you need to replace with, if you have AND, you need to replace with OR. Means whenever you have OR, you need to replace with AND. Whenever you have AND, you need to replace with OR. So this is the principle of duality. Not only this OR and AND replacing, so we also have the true statement and false statement. Means whenever you have true statement, you need to replace with false statement. If you have the false statement, you need to replace with the true statement. So here, if a compound statement S1, let us suppose here S1 is a compound statement that is called P or Q. It is replaced by OR by AND or AND by OR. So as we have here S1 as OR, then you can replace with AND here writing P and Q. So and OR by AND, then S1 is a tautology if and only if S2 is a contradiction. Means if this is a tautology, then we can replace with the contradiction. So here the dual of, so we have 2 examples. So here we observe the dual of P or Q and R and S or F is P and Q or S and true. That means this P or Q we have written here, this OR is replaced with the AND here, AND is replaced with the OR, and here also we have AND is replacing with the OR, and here we have OR replacing with AND, and we have F that is replacing with the true. Means wherever you have OR, you just need to replace with AND. Wherever you have AND, you need to replace with the OR. So not only that, true with false, false with true. So see the second example. The dual of P and negation of Q or P and Q or negation R. So here this AND, it is becoming OR, and here OR is becoming AND is becoming here OR, and if you observe, OR is becoming AND. Means this is S1 is one compound statement where you will have some variables also, P and Q or Q or R. Some question. Now S2 is nothing but it is a principle of duality where it is obtaining by replacing OR with AND 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 with OR. That means here P or Q and Q and R. So this S2 is called a principle of duality as we have applied this definition here. So this is about principle of duality. So what we have discussed today is what is meant by a logical proposition, what is logical implication, what is the definition of logical implication, and we have seen 3 examples. So first we have seen one condition first, and for each and every condition we have discussed one example by constructing the truth table, and also we have also discussed principle of duality. So this is about our session. So by this we'll end the session. Thank you.